los asistentes en los diversos canales YouTube que se unen a esta conferencia. El día de hoy, jueves 21 de abril. Para nosotros es un gusto, como Universidad Nacional, tanto para la Facultad de Ingeniería como para la Facultad de Ciencias Económicas, tener a la empresa Metro Línea 1 en esta serie de conferencias durante estos próximos 5 jueves. Se han unido entonces a esta conferencia el jueves con los egresados de la Facultad de Ingeniería, la cátedra con los egresados y la cátedra empresarial de la Facultad de Ciencias Económicas. Mi nombre es William Castro García, soy profesor de la Facultad de Ingeniería, actual coordinador curricular de la carrera de Ingeniería Civil. Y para la sesión de hoy vamos a invitar al ingeniero David Wang, quien nos va a hablar, no sé si podemos allí proyectar su hoja de vida. David es vicepresidente e ingeniero jefe del departamento de diseño de la empresa Metro Línea 1 S.A.S. El señor David Wang es ingeniero civil senior, profesor asociado graduado de la Universidad de Hohai en Nanjing. Además es un ingeniero registrado en el Consejo Profesional Nacional de Ingeniería, el COMNIA, en Colombia. Cuenta con bastante experiencia en proyectos de infraestructura en China, Myanmar, Macao, Ghana, Reino Unido, Sri Lanka, Colombia y Canadá. En este último país acumuló 10 años de experiencia laboral en la industria residual y de petróleo, gas. Además cuenta con 16 años de experiencia en diseño y gestión de proyectos internacionales a gran escala. 3 de los proyectos en que participó ganaron importantes premios: el premio Luban para la Terminal Internacional de Contenedores de Yantian, fase 2, en Shenzhen, China, año 1999, el premio Shan Tianzhou para la Terminal Internacional de Contenedores Yantian, fase 3, en Shenzhen, China, 2006, y el premio ENR al mejor proyecto de puerto y aeropuerto del 2020 por Colombo, ciudad portuaria en Sri Lanka, año 2020. Quiero entonces dejarlos con el ingeniero David. Durante unos 60 minutos él nos va a presentar el primer tema del día de hoy sobre los, no sé si podemos allí proyectar el título de esta primera sesión: Detalles técnicos de la primera línea del Metro de Bogotá a nivel de transporte y movilidad. Entonces, bienvenido, te cedo la palabra. Muchas gracias por tu asistencia y a todas las personas de la empresa Metro Línea 1.
Okay. Good evening, everyone. Sorry, where is it? Hello? Okay, good evening, everyone. So my name is David. Today is very proud, is my honor standing here to give some introduction and brief to the railway system, which is where we're building the first line of Metro Bogotá. Yeah, before starting my presentation, I would thank you, the engineering department and the economy department of National University of Colombia, with the invitation to ML1 to sharing the information of the project and some knowledge of the railway system with the students. So tonight I'll take about 60 minutes to go through the project information and some brief on the railway system in the design and construction, and installation, and testing, commissioning, and operation. Okay, so give me 1 second. Okay. Right. So the first slide is about myself. Oops, where's that? No control for me? Okay, I'll use that menu. This is myself. I believe William just gave you guys a brief of my my career. Okay, so that's my experiences. I have about 26 years working experiences after graduated, and covering some countries. Okay, I won't spend much time on this slide. Let's start for the presentation. So, would you mind tell me, or you have any feelings about the metros? So do you think any like advantage or benefit for the metro line for the city? So anybody can have 1 or 2 points in your mind, or you want to share with us? Okay, so can you, excuse me, can you give the microphone?
Well, I think that one of the advantages of the metro line is that we are going to have we have a high demand in transportation of passengers through the Caracas corridor. So it's pretty necessary right now. I mean, it was necessary 30 years ago. So we are trying to fill a demand that has existed for several years, and we haven't been able to attend. Okay. So that's one of the benefits that have the Metro Line 1 right now, and I think that is one of the most important ones.
Okay, thank you. Good point. Okay, anyone else? Yeah. So.
Well, good evening.
Hi.
I think one of the major aspects of the Metro Linea is that it will be like the first experience for Bogotá on having a railway system. So it will be like the opener for next lines. You know, there's a big necessity of having more and more lines, not only of metros, but also on trams or maybe I don't know, like trains for the metropolitan city. So it will be like the first experience for us, and it will be the open door for next experiences in railway systems.
Okay. Okay, thanks. Last one. You have any ideas about the advantage, benefits for the metro? Anybody else?
Hi, good afternoon.
Hi.
I think the main advantage is that it will connect these sectors of the city that are poorer with the center. So this will benefit and impact the life of millions of people along the corridor. And I think that social benefit is something that, as a city, we needed to connect, to have these systems from these areas to the center of Bogota.
Okay. Yeah, good point. Because that from not the point from the transportation itself. Okay. All right. I think you guys have got some major point about why we have the metro line for the city, right? Look at other country, almost in most of the capital city, we have the network for the metro line. And Bogota is the capital of the country, so I think this has to be the one method for the public transport. All right, so metro line, compared with traditional public transit, we have the trains on the track, okay? There won't be any traffic. As we see the people driving the vehicles on the street, we have to stop on the traffic line and wait for a long time. If there's any accident happened, the congestion's coming out. Secondly, we use the electrical power to drive the train. Okay, there's no any carbon emissions to the city. Okay, and we take the passengers, the large number of the amount of the passengers at the same time, the same directions. Okay, that gentleman got a point. Okay, this line coming across the city from crossing the different zones, different areas, right? So from the residential to the commercial to the governmental, or they will move the people around the city, giving the people the opportunity. I mean, for the movement, and will change a little bit for the development of the city. These are long term. Okay. Let's go back to the presentation. Okay, today we're going to bring a little bit of new product or new procedures for the metro line. So anybody has any ideas or having heard about the ramps? All right, so okay, so I think that's the first lectures or open classes. Lately, we'll have another 4 classes by my colleague from Metro Line 1. Okay, back to ramps. Simply, we call it as the reliability, availability, and maintainability and safety. So we take the first capital words and come up with the ramps. So what do the ramps will help the metro line in operation? So the following slide, let me drive you through, okay? Okay, so today we're going to take that 16 minutes going through that the background or the update of the first line of Metro Bogota, and we're going to introduce in general of the ramps procedures, and we're going to go down to the project, the ramps objective, and we're doing now, and what we're doing on the ramps at the moment. And the last part, we'll have some question and answers sessions. Okay. Right. Can you look at it clearly? A little bit? If you want to look at it, you can come closely, because I know that the light is a little bit. Okay, so that's the general layout of the project. We call the first line of the Metro Bogotá. Before going into the details, so I would say the first line for the city, first the metro line for each city is quite important, because we'll design the metro system from the first line, all the standards, rolling stocks, and systems, and the basic like arrangement or configuration of the metro line will be from the first line. So the second line, third line, so any lines after, so they're going to follow the same rules as long as they're in the same network. Okay, so that's why first line of metro is quite important for the city development. So that's why the Metro Bogotá took, I don't know, few years to finalize the feasibility study for the line. I believe everybody in this room knew the history of the project, the up and down, whatever. So finally, we decide to build this metro line. This line is about 23.96 kilometer long, and we have from here, from this end, and going east, okay, and from here the line will build on top of the Caracas Avenue, and we're gonna terminate this at the 76th Avenue. Along the line, we have 16 metro stations. So, and from here, we starting meet with the Transmillennial, like we call BRT. So from here, we will go along with BRT lines on the Caracas Avenue. We have 13 BRT stations, and most of them will be upgraded, because this BRT station will come up with the metro station. So there will be the interchanges. The people coming in and out from the BRT at the stations will easily go into the metro line. So that's really help the people. I give the people another selections of the transportation. So if you think that there's an accident on the Transmillennial line, so you can easily go up to the metro. Okay. So for the structure-wise, you can see these cross sections along the line. So we have 100% elevated metro line. So you will see in the future the train running on top of your head, and so. But we already consider the noise and vibration impact to the neighborhood and to the city. I'm not sure. Okay, here we have a list up some disciplines for these whole lines, right? We generally we have two groups, and firstly is the civil work. You can see in the future, maybe early next year, we started the construction activities in the city. So we have the viaduct. We call this viaduct, these kind of superstructures, and the foundation of the viaduct. We have the pile foundations at the moment. After the precise geotechnical investigation done along the line. And we have the main corridor including everything other than the viaduct. We have the public spaces, we have the urbanism designs, we have the pavement designs, and network, I think we have another one, okay? And there are some special intersections, like 72nd underpass, now is under construction. If you are aware of that, we are already starting doing the excavation to the underpass. And we have a AV68. This is quite important transportation or traffic, like we call it a hub in the city. I have been there many times during the past 2 years. Yeah, it was quite busy at the roundabout. We have the vehicular bridges crossover, but at this area, so we're gonna rebuild the new bridges. We're gonna put the metro line in the middle. So it's very huge works to do. So we're gonna demolish the existing bridges and to build the new bridges, and the metro line we're going through in the middle. And the 13 underpass, yeah, they will be integrated with the latest regulation we call the PLMB. That's the heritage zone protections from the Avenue 10 to 12 at the downtown area, right? We decided to develop this underpass at the 13th Street to make the connections to the BRT station and the new metro stations underground. Okay, metro station, we just talked about. So we have 16 metro stations, but with the function for the 16 metro for each stations are differences, okay? We have a commercial area inside the stations. We have an access building from the both side of the road, and we have the bridges connected to the metro line to the platform level. And we have BRT stations. This BRT station will be a little bit different from the existing outlook. We'll build a little bit wider and accommodate more passengers coming through from the BRT station to the metro line, and from the metro line to the BRT station. Okay, the depot located here. Okay, we have a 34 hectares area for the depot. So what's the use for the depot? Is for the rolling stock, the train coming out from here every early morning, and they will going back home. This is like a home of the depot of the rolling stocks. In this area, we have the storage we call garage for the 30 trains. So in one train we have 60 cars, 60 sections. We bring them together as one. We call one trains. We have 30 trains in the garage, and we also have the maintenance building and the maintenance warehouse, and for repairing, for like maintenance in the regular basis for the rolling stocks. And also we have some admin building and testing trucks in this area. So this is quite important. So every day, day and night, the rolling stock will be from there. And next time about the MEP equipment that, like I said, the network locations and the new water system, power system, and the gas line communications and telecommunications. Okay, so it's quite important to the metro line. SER is the main substations for the line. As I said, all the power generated from electricity. So we have 3 SERs down the line. First one is inside the depot. So second line is right here in the first street. And the third one is located at 72nd Street. So that's 3 main substations providing the power for traction, for all the rest, for the high voltage, mid voltage, and the low voltages. Okay. This is quite important. This is the power resources for the line. Okay, the other one is about the railway system. We have a rolling stock. The rolling stock looks like here. I don't know whether you can look at it clearly here. This is a green one. So, okay, the color was finalized. So now the mock-up of this rolling stock is under construction in China. So hopefully you will see the mock-up I don't know, not shortly, maybe in a few months. The mock-up will be displayed in somewhere, I'm not sure which park in the city, and everybody can have a look, take it on board, and look at the interior situation, chairs, handrails, whatever, and you guys can provide your comments to the city, to the metro line. So we will do the improvement if the comments is quite valuable. Okay, and the truck, and this is the next one about the CBTC is the train control and signaling. This is quite what we call that, because the signaling, like communications, is quite important for the metro, because that's like the two people talk to each other, right? So the train and the systems, the control systems, they will talk to each other, and they will give the train knows where it is and where the train ahead and when the train behind, and what's all of the information coming out controlled by this design by these signaling systems. Okay. Another one about the S.A.S. is the control and supervision subsystem. This, I think you may saw this picture somewhere. You can see the operator center, control center, with a huge screens. Okay, the trains on the screen showing the updated the train locations and conditions. So that's the S.A.S. Okay, they control everything, communications, radio communications, and telecommunications, and the timetables and whatever, everything, and also the the radio system in the metro station. Sometimes you will hear the notice from someone operator say, hey, this train's delayed, and this train, whatever, this announcement system. And the power supply, as I said, generated from SCR, and we get a SET and CET. Just for the different circles of the power system. Okay, communication, telecommunications, like I said, is also the core control system of the metro line. Yeah, without them, the train will be blinded. They don't know, because I'll show you in the next slide why this kind of system is quite critical for the metro line. Okay, so the access toll control, just like the barrier. So you can, I think that's in the BRT station. Okay, you paid, you got a ticket, you touched it, the barrier let you in. So this is the system we call the AFC in the metro. Okay. And the PDAP is also another door called the sliding door or platform screen door. So we build up on the platform here. The other side is the train. Okay, when the train stops it, the door automatically opens. The passenger coming out, the new passenger going on board. Okay, so this also the system have to get integrated with the whole train control system. So they know when the train coming out and the train stop it within some allowance. Okay, if the control is not that precise, the train going this way, the door is here. The train door and the screen door has to work together. Okay, the depot equipment, In the depot, as I said, we have a lot of maintenance works, testing works, and so that's in the depot. We have multiple equipment. Some is for repair, some is for the truck maintenance. So that's also important in the maintenance and for the operation. And the last one about the truck. Okay, so our train is the power supplied by the third rail truck. So you may saw that in some trains they have some racks on top of the roof, right? That's also the power from the top. But our metro line from the third rail, we have two rails taking the train, and we have another rail beside it, and we have a brush from the train. When the train moving, the brush touch the third rail, the power from there here. Okay, so that's our way to run to track. We call the traction power through the third rails. Okay. Yeah, if you have any questions, please feel free to raise your hands, so we can have a further discussion. All right. So this slide is showing some key parameters of this line. Okay. We have a maximum capacity per day, 1 million. This is the maximum capacity for the rolling stock for the whole systems. And we have a capacity, time capacity for direction. So one direction per hour. So we have a one direction per hour. The maximum passenger on board is 46,300. And this 100 second means a headway. Okay, that means two trains, the time interval between two trains is shortest is 100 seconds. So that means in the peak hours, so we got more trains on the line, but we have to maintain 100 seconds between the last vehicle and to the first vehicle of the two trains, okay, for the safety issues. To get this 100 seconds is quite difficult, because the signaling system has to contribute, and the communication system has to work with signaling. So all this system can be work to the maximum capacity to get this one, to get 1 second. So these are quite ultimate conditions. And the other one about the speed. Commercial speed is 42.5 kilometers per hour. That means the normal speed. But the maximum speed, design speed, is 90. So the train can run on the track maximum on 90 kilometers per hour. Okay. And first of all, in our concession contract, we have 30 trains at the starting of the operation. Okay. Otherwise, the other one about the social issue, right? We have a 19 kilometers long cycling path. That's included in the main corridor scope of work. Okay, and we have the bicycle parking area spaces at almost every metro station. So everybody like to ride the bicycle to approach the metro station. No problem. We have the spaces for your bicycle. Okay. Okay. And then we talk about the rolling stock. Okay. So that's the picture for the rolling stock we're gonna make. So per train, we have the whole train. We have 60 cars here. We have 6 cars becoming at one train, and that for the one train full of the passengers, we have a 1,800. Okay, and the length of the one train is 135, and the width is 2.9. So let's go next. All right, let's talk about time for this metro line. Okay, we have design phases. Now we still in the design phases. It's 27 months. Now we're at about 66, 67% of that progress. So after the design phase, so we're gonna enter the conduction phase, which is 57 months. So within this 57 months, we're going to build all the sessions that I show you in the previous slide, all the civil works, and the systems going to be installed, and also the rolling stock will arrive, and it's been tested, and after the construction, we got like acceptance from the Metro Bogotá. We're gonna have 6 months for the testing commissioning. So within the 6 months, we're going to test out the whole 30 trains with very complicated procedures, with different scenarios on the line. Okay, maybe at that time you can see the train starting running. But it doesn't mean that we start operation. It's just a testing. We have to get a 20 how many hours testing past that, so we certify this train is fine. Okay, with suitable or accommodate with the railway systems. So this is the key time. So when we finish testing commissioning, we'll get a certificate from Metro Bogotá and another independent assessors. After that, we start 20 years operations. Okay. Within during this 20-year operation, as a concessionaire, we have to fulfill some requirements for the operation, with some like detailed like requirement for every single subsystems and the civil work. Otherwise, we're gonna have a problem, right? So Metro Bogotá, within the concession agreement, we have to run the system, run the whole metro line under this kind of a specific requirement for the operation. Okay. Okay, this one is presenting the technical requirements for the concessions. We have we call the technical requirement. Here we use 80, 81 to 8020. Okay, so including the regulation and the management testing, commissioning, and the civil works, viaduct, architect, and rolling stock, metro, railway, and ramps here, and operation maintenance requirements, and indicators, and land acquisition, utilities, social, environmental, traffic, and the execution plan, and handed over procedures. Okay. So we'll do all the works in complying with all these documents. All right. So this slide is showing 3 center lines. That's from the concessionaire's understanding to make the best metro line for Bogotá. First item about times. Okay, we have a 90 months for design, build, testing, commissioning, and 20 years for operation. That 90 months for us is quite tight because we have to consider the whole system or integration interfaces during the design phases and construction phases. Also very difficult because everybody knows the construction in the city. We have to look after the social, environmental, and also the traffic impact. Okay, so we're preparing for that, but apparently it's quite a challenge for us. Okay. And secondly, about the beam, I believe most of people knowing the beam, right? So because at the moment it's quite popular, is the building information modeling technology. For this project, we were requested to adopt the beam technology from the design to the operation. We call the life cycle of the project. Okay, so all the designers will starting the design from the beam or all the surveyors, the contractors will everybody work on the beam, right? Like we do the Lego, right? Everybody will put the brackets on that from the design stage, from the construction stages, okay? So, and from the testing, commissioning, and operation. So the beam will be coming different outlooks in different stages. So, and third one is about the ramps. That's the topic for today. Okay, the ramps gonna be through the design, procurement, construction, installation, testing, commissioning, and operation. So we're gonna have details in the next few slides. Okay, so let's present some updates for the project. So we're on the design, under the design stages. The design, like I said, the design progress is about 68%. Okay, we have different packages. The percentage is right here. So we're just about right on the time. Okay. And we have a topographic survey finished. We have geotechnical investigation almost done. And network inventory location designs inventory was done, and the detailed design is ongoing. Is to be finalized in the next 2 months, I think. And the 72nd underpass and the depot is under construction now, as planned. Okay, so I have some little video showing the design works now. This should be something that's generated from the beam model. Okay, is okay for you guys? This is a metro station. Is the roof. Yeah, that's better. Yeah, maybe we just go this way, okay? Yeah, you don't need to look at me, okay? Look out there. Songs. All right. No? Yep. All right, so if you have a question or interested to know the beam technologies, you can contact myself, okay, after the presentation. We can have another time to go through that. All right, so from this slide, we enter the main topic of RAMs. Okay. So let's talk about the grade of automation. So that means the train operations, right? Driving the train. Okay. We have the grading levels. We have the driving mode, train controls, platform services, stopping, and the train door controls, and the train departures, and operation control and the distribution. This development or the history of this grade GOA, we call. Okay. From GOA1, we have menu. You can see all this menu. Okay, and the driver is on board, manually driving the train. Okay, lately we got a GOA2, we got an ATO, like automatically train operation system. You can see we got a train control out and the platform services automatically, but others were semi or pure manual. The driver staying in the room, but maybe just touch a few buttons, right? For the train controls, starting the train and open the door, close the door, right? And we have a GOA3, we call the with the DTO, the driverless train operation system. The driver on board, but he's not going to be drive and just open the door, open the platform door, close the door, and check the passengers and others all automatically. And the latest one is the grade 4, GOA4. So you can see the UTO like an unattended train operation. That means no driver, right? With the other three, the driver is on board, no matter did you drive or not drive. But for GOA4, definitely you won't see drivers on the train. Okay, you can see this with the UTO scenario. So we have everything in auto. So that's the first line of Metro Bogotá. Okay, then I would ask you a question. Do you have any worries when you sit on the train without driver? You have worries or not? How the train gonna recognize the destinations, recognize the speed, stop, and recognize when the passenger is going out and come in. So, and they won't hit the one ahead, and they won't get hit by the train after or behind it. I don't know. You feel safe on this kind of train? Yes or no? No. All right. So. Yeah, so that's the RAMs works. Okay. So the RAM systems, let's look at the next one. Let's talk about the UTO first. Okay. The intended train operation UTO scenario for the metro. So going through this one, we identified, before we do the designs, we have to identify the operational scenario with this and with no driver condition situation, okay, by the whole stakeholders or the parties get involved, okay. So we have to take into account all the failures or the critical failures from each one. Okay, and we come up with the solutions and the mitigation plans. Right. For example, we're gonna no power for the train. Right. The third rail lost the power. Okay. So the train there's no brake for the train. The train will be slowing slightly going stop. Right. So because the power supply will be section by section, right? If the train is sliding past this power lost section, they receive the power from the next section, no problem. They restart the automatic the GOA4, so they will wake up from next session. Okay, if they stop before the stopping, there's no power at all. So that's the train behind, the train ahead will all stop, and the passenger will be rescued or activated, and it will wait. And we have some backup battery in the rolling stock, but that's not gonna providing the power for traction. They're gonna providing the power for sending the message, sending the alert to the operation control center. Let them know, hey, this train lost the power, is gonna stop. And the direction or the rescue from the order from the operation center will be directly given to the host systems. The people or will be going on site, fix the power supplies. Right, just an example. Or sometimes we lost the communication, like between train to train, between train to truck systems. Right, we have to have a different scenario, different strategies, plans to make sure that no accident happened. Okay, sometimes the train slowing down to the 5 kilometer per hour, right, and moving to the station close by, and let the passenger going out and wait for another train to push this failure train to the depot for repair. So this kind of example, they have a very detailed scenarios from the depot, from the CCO. CCO means the control center, operation control center, and from the main line, these operations. So we have this UTO scenario to include all the critical failure conditions for this kind of a GOA4, no drivers conditions. So, okay, so we start to talk about the RAMs. Okay, like the first slide, we all know the RAMs is reliability, availability, and maintainability and the safety. Okay. So they describe different sectors of the security of the operation. Okay, reliability means with the failure for time intervals and given conditions. Availability is about the item to be stayed as perform required functions under given conditions for the time and intervals. And maintainability means they able to be retained, okay, restored, and so all this RAM, we call RAM, is talk about the compliance. Okay. talk about the failures, how to comply the failure. And the safety is about the hazard, we call the risk controls. Okay, that's a general. That picture, besides, we have a railway system here divided into two groups. We have the transport system and access systems. Okay, transport system means the train running on the main corridors. So including the truck system, S.A.S, mean the supervision systems, and the power supplies, traction powers, and the CPTC is the signaling and the train control, and the platform doors, like that we talk about, and telecommunication and the radio communications, and AFC means the toll barrier systems, and the rolling stock with the train, and the civil work, mainly about the MEP, the mechanical, electrical, and the pipeline. Access system means how to access to the train. Okay, we have the activator from the in the metro station. We have the lift and the activator elevators. Okay, and also we have the depot equipment is under both. Okay. Well, from here is a little bit academic, so it's quite a basic from a definition and formulas. Well, I think we can share this presentation after this open class. So the reliability we normally count by the mean time. But the mean time between the failures, or the failure rate is the mean time between failure. We call MTBF is their reverse. At the moment, the mean time between failures describes the times between two failures as the repairable system. So this is the sigma adequate operation time and divided by the number of the failure. This is some example here. So we have a failed 100 hours, the second fail is 120 hours, and third failed is 130 hours, and the mean failure between mean time between two failure is this 160.67. So that's all the basic knowledge. Okay, the availability is the ratio of the total time of a system is capable to be being used during given intervals, which includes both operation and all the downtime. We call it downtime means the system or any subsystem having the breakdown, the times. Okay, we have the downtime and uptime. Downtime means this system stopped working. The upper time means back to normal. Okay. So we have the availability formula is the mean time between failure and divided by the mean time between failure plus the downtime. So that means if the downtime is 0, the A is 100%. Okay, the 100% availability. There's no any failure. So the downtime means the mean time between failure and divided by this MTTR is the time for repair. Okay. And the downtime coming up with this, starting of the uptime and the time back to normal, and we consider the time starting from the downtime. So that's the period for the real time of stopping work. Okay, so next one about maintainability. Maintainability is quantified as the mean time of repair. The mean time to repair is like a kind of a maintenance for the failure. So the end of the repair, the time for repair is about the end of correction. Corrective action means repair. Okay, it doesn't include the logistics, like the person coming out from home and they take the time to the site. It doesn't consider this kind of logistic times. Just consider the pure repair time of the systems. Okay, so yeah, move to the next one. And safety. Okay, like I said, the safety we described as the safety integrated level. We call SAIL, S-A-I-L. So this is the risk categories. We call the SAIL level here is the hazard rate, okay, per hour per function, right? You can see this it's per hour. The opportunity or the likelihood is really its differences. So SAIL 4 is the highest, but that means the risk, when the risk happens, the damage or the loss will be very critical, but the likelihood is very few, is very less. Okay, and on the other hand, the SAIL 1, okay, the frequency may be quite greater than SAIL 4, right? But the impact from this kind of failure is not that much than the SAIL 4. It's kind of a concept of the risk management, I think. All right, this is about the standard, okay? This is the general standard, Euro standard 50126. It's about demonstration of the ramps. Okay, and we have this for the entire railway system. We have the generic standard, which are here, railway subsystems, right? We call the electrical, electronic, and programmed electronic, I think, yeah, safety. So I have the description here about the international standard to do the analysis of ramps. So from this point of view, you can see the standard for this metro line is really high, and we were requested to use the most latest international standard for design and from the design to the operation. Okay, this one we talk about the system life circle. You can see at both sides of the slide, you have different shapes of system life circle. With this one, we call the sequences in the phase. Okay, from the concept and going down to the design, finish the design, and we start the manufacturers, integrations, the system validations, then in testing, commissioning, and the acceptance operation here. And the decommissioning means we finish our concession, we give the project back to the city. Okay. On the other side, that's most popular shape for the RAM system. We call the wave shape. From this half, this half is about the process before or for designs. So during this stage, during these phases, all the ramps requirements we'll do the modeling assessment or analysis with collecting the data. This is a phase. And from after that, on the other wing here is like from the manufacturer installation and the testing commission and validations and acceptance is the stage to demonstrate the RAM's compliance. So that means this half we design for that with the required RAM's compliance. But on the other way, we're going to starting manufacturer selecting the product to demonstrate this system could work as designed. Okay. Next one. All right. So, any questions about that? It's a little bit. If your first time saw that, a little bit hard. Yeah, no problem. So, if you have any question, please raise your hand. So, this section we're going to talk about the Metro Line 1, the objective for RAMs. All right. So now we divided from RAM and the safety, okay, because they have separate requirement or separate objectives according to the concession contract. So, all right, so the RAMs covering the transport system and the access system. So here's the detail of the transport system that I show in another previous slide here. We have a technical requirement, okay, development life cycle and the RAM activities. So every phases we have separate objective. We just showing you guys these are 12 phases on the V shape. So every single phases we have to produce different objectives or the designs to or demonstrate to fulfill the objectives. And the RAM plans integrate with the integral system and the main study in the detailed studies, manufacturing installations, and on-site testing and the integration testing, and also the final the testing, commissioning, and operations. So you can see the technical requirement is from the design all the way through to the operation. That means the RAMs will watch all the activities regarding the security and the safeties and for the whole time life cycle. And we also have some management requirements, which is quality management. And for the manufacturers, you have to fulfill the quality during the manufacturing. Okay, installation as well. So the quality management is also critical for the RAMs. And the configuration management plan. Configuration, that means that's keep the information updated and keep everybody, all the party informed at the same time. So for that project, normally, for example, for the designs, right? We have I think 40 disciplines working together, right? So some discipline change the designs or having some demand or request to change, but the others didn't know that. So and in the future they may make the mistake. They work on the previous version of the drawings or the document. So configuration management just to solve this problem. So we have this whole system to pump up the design, any changes, or updated the standard requirement on the same systems. Everybody have to work on that. If anybody changes, have the changes, you will get an alert or the message. Okay, and make sure everybody use the same version of the document. for design because the railway system, we have a really large number of the disciplines, right? Not like normally the road and bridges, but system or even the civil work and systems and the road metro, we have to look at every single second. If anybody makes changes, make sure all the rest are aware of that. Okay, so that's the RAM's life cycle for this project. So you can see we have defined the RAM activities per phases. Okay, here we only have 11 phases. The number 12 is handed over. Okay, so every phases we have a different RAM activities from the concept. Okay, right? We have to we will start from the requirement for the technical appendix, like the contractual requirement, and next one we'll do the risk analysis, reliability analysis, and maintenance and analysis, and for that different times that we show you guys in section 2. Okay, and system requirement, we have to establish the RAM plans at this moment, and distribution of the system requirements. So we're gonna have the system or project level, the requirement, and we're going down detail to the system level and going further down to the subsystem levels. And we have the bottom level is the equipment levels. Okay. So, for example, the project level, we're gonna RAMs at a 99%. We distribute this 99 down to different subsystem and down to the suppliers, the equipment suppliers. When we ask the supplier, hey, give me the equipment, we have to give, as requested, certificate or the record of this kind of failure. The RAMs data with the product. If they don't have it, we have to find another one. Okay. All right. So from the number 7, from here, phase 7, we enter the production. So the quality guarantee is coming out. Okay. Well, for the manufacturing, installation also quality is here, and starting acceptance is about is about the installation, I think. Okay, and the demonstration about the testing, commissioning, and during the operation we're gonna provide the maintenance operation or repair the policy. For example, the train, we have some irregular basis checking up. So the different policies giving different, this kind of OPEX, okay, the cost proposal, okay. If we check the train in daily basis, okay, or we check the train in weekly basis or every 3 days, so different policies becoming different maintenance cost and strategies, but we have the baseline, not baseline, the basic requirement in the concessions, meaning by how many kilometers the train gonna get the light maintenance. So with how many kilometers the train will be the major maintenance. Okay, so that's brief in the introduction. So if I speak more, it will take a long time. Oops. Okay. All right. So that's the detailed RAM requirement for the Metro Line 1. Oops. Sorry. You can see this is a global. From the first 2 years, we have to get first, with the start of the operation, we have to fulfill the 98% of the RAM. And the end of 24 months after the operation, so we have to reach 99%. You can see we have a interim requirement at 6 months and 1 year. So we gradually reach the final RAMS requirement. Okay, so 99% means we have different categories of a failure. Okay, we defined the significantly if you couldn't rate this, we should rate this delayed longer than 5 minutes for the whole line. Okay, it will be the significant failure. Okay, and secondly about the major. Major means less than 5 minutes. Okay, and the third one, the minor, without delays. So this is quite critical. I think you guys should feel safe with this kind of requirement. Okay. Okay, to come up with this target, so every single subsystems we have different RAM requirement. You can see here this the requirement at the end of 24 months. So you can see here is 99%, but for the truck we have a 99.991. Okay, and for the power system, it's quite critical. We have a 99.997. Okay, and we have signaling also the same, right? And the telecom, we have a even greater than that is 998. Okay, and in this table you can see which system is quite important for the GOA4, for the UTL. Okay. So you may have a question how to generate or calculate this one, and we got a result of 99. Okay. So at the moment we have the software to do this kind of modeling. So we just input this requirement, run this program, so we can get the result. Okay. Okay, this is quite small. I wouldn't like show you guys this quite detailed requirement for RAMs. You can see the downtime here, the mean time between failure. Here we have a very specific requirement for every single subsystem. This for the repair time. This for the demonstration period of the technical availabilities. So, but generally we have different levels of requirements on the RAM, on the reliability and availability and maintainabilities. So when we design the system, all the products, all the systems has to comply with this requirement. All right, so that's the deliverables. Also, it's quite small, so I wouldn't explain more about that. So this kind of, I just want you guys have the idea. So we have the deliverables, not only the analysis. We have to check the system with the report, with the analysis report, risk and hazard of no hazard, failure analysis. So that's, we divided into different phases. We have 60% and 90% and 100% of design stages. Okay, and the test and commissioning, we also have the RAMS activities, and also the operation. So some activities is all the way through, and some activities come into the middle. Okay, but at the end, the whole system going to be recorded, analysis with a good result, with full compliance. All right, the safety. The safety is more about the risk. Okay, so we have this compliance by RAM, And the safety is talk about the hazard and the risk controls. So how to control the risk to guarantee the compliance for the railway system. Okay. So for the general requirements, we have the risk identification. So that's quite normal. We have a LARP is as low as reasonably practical. So this is the method for the safety analysis, and that means in general is to make the good enough solutions. It's not the best solution, not the zero risk, but it's not on the other way. So we should get a balance point, like we call the good enough options. Okay, and others about the human factors and hazard log. The human factor also is quite a specific stuff for the railways, for the train systems, right? This to stimulate the people, the humans movement, and in the metro stations or whatever. So this gave the data to the designers to make sure the design is making the people feel comfortable, or is no any accident during operation. Okay, we have the technical, so safety plans, technical requirement. We have hazard logs and safety risk criteria, and so all this one about the safety, and also we have field test and railway system or the service system of the safety plans, and so you can see this all the risk all the way through the risk management, the safety. Also the management requirement, the quality also there, configuration also there, and the transition between the installation activities and to the testing activities. Okay. Go next. We have to go faster. All right. So this is the life cycle for the safety. So similar with the life cycle, the V cycle for RAMs. So we have a similar activities for the different phases. Okay, and so from the beginning we have to establish the safety management and understanding the requirements and safety plans, assign the safety requirement to the subsystem. The same as the RAM, we have to go different levels of the safety requirement for the systems. And I think it's from the production here, phase 7, we're starting the safety specifications and the quality guarantees, and all the way down to the final evaluation of the safety data. Okay. All right, so that's the objective for Metro Line 1. You can see this, you may be familiar with this. This is about the criteria, all this table is about the risk management. Frequency is defined, different ABCDF, different categories of the frequency of the risk, and the risk matrix here, we call ABCD, and the sales categories here again, level again. And we have a severity categories, so that's the impact of the risk, okay? And the safety objective and combined with the CO level. You can see the CO level 4, R4, we call R4 and CO4, will be the right hand upper corner. So this kind of a critical, but with less frequency, okay? Right, so that's the safety objective for. I combined this objective between the common and the subsystems. You can see this different, what do you call that? different category, different phases, I think. Okay, and we have a different requirement for the subsystems. The number here is the total number of the requirement. For example, for the signaling, we have a 21 requirement on safety. Okay, and we have a 41 for rolling stock, and we have a 37 for the operation and maintenance. Okay, you can look at this number of the requirement. You will know how critical, which system, subsystem are critical. All right, so that's, again, this the deliverables of the safety. We also have a different list of the deliverables for different stages of the project. Okay, so this the safety. This is system integration. This is a subsystem. So all this chart is showing you guys the relationship between the system and the subsystems. You can see most of them, the deliverables are the same. Okay, the last point about the ISA. ISA means independent safety assessors. So why we have this? Because they are on top of we done all the safe RAMs activities. We deliver all the documents for RAM. We show the full compliance with the requirement in the concession. So if we have this kind of independent, like company or entity to check again, so they're adding more securities on the system. So okay, so what are they going to do for this independent party? So they're going to in charge independently assessing the safety management done by us. Okay, in charge of the subcontractors, not only the concessionaire, they will check also the RAM's activities, analysis, or demonstrations from the subcontractors, the suppliers. So under the concessionaires, okay, and also independently conduct assessment according to this ISO standard. Undertaking the public transportation operating system, and to conduct the evaluation assessment of all activities during the life cycle of the concession. So they're going to check our RAMs activities in details. Okay, they will come to our company and to check all the documents. And if they have questions, we have to answer. Okay. And to undertake a safety assessment audit, that I'm talking about audit, to necessary whenever they said they think it's necessary. Okay, to carry out a technical review focusing on the particular technical issues. So you can see they're powerful for the RAMs, or especially for the safety. Okay, to issue the safety certificate of acceptance of the testing commission. That's quite critical. Without this certificate issued by ISA, we're not able to start operation. So we have to fulfill all the ISA's review and check, and they will if they satisfied all these our report and the results. So we'll go ahead starting the operation. So we have done the first audit last month by the company that's in our office, and that's the report they produced. The result was good. All right, so that's about the main part of my presentation. At the end, I would say we should. For the RAMs, I think we should always consider integration and interface and the compliance, risk controls, and the configuration and the quantifications. So because all the analysis is not it has to be done by the like the details analysis. Okay, and we also have to look at it, the quality and the life cycle, and with the S.A.S certified. All right, so let's read again the reliability and the availability, maintainability, and the safety. So in our minds is maximum secure our system operation and protect your travel. Okay, that's our concluding thought. Okay. So any questions? It's the time to do the answering. Okay. We have a few my colleagues. Let me introduce Jackie Lan. He's from Hong Kong. He's the specialist for ramps. Yeah. And okay. If he will help me on some hard questions technically. Okay. Subsystem is our ramps engineer. Yeah. Okay, and Christian is our rolling stock engineer. He's also your alumni, graduated from National University of Columbia. Okay, yeah. Thank you. So any questions we can? Is very tired? Oh, right there.
Hello. What are the principal problems that you have found by implementing that metro line in Bogotá?
At the moment?
Language, I don't know.
At the moment?
Yeah.
You mean the problem? I don't think it's a problem. It's some challenges,
Yeah.
right? Okay. Because this project for us also is quite is like large scales for the infrastructures, right? It's also the first line. Some challenges for the city, right? We work with Metro Bogotá, right? Because and there are some like some regulations. We have to rate all the regulations about the urban development, right? If we miss one, we're going to be in trouble, right? For the urban plannings, they said, okay, we need a cycling paths here, we need the urbanism in the other side, but we have to go through whole regulations. So that's sometimes it give us a hard time to get all the informations there. Right. Also, we have to coordinate with, like, for example, the Transmillennial, with EDUs, with all the public entities. Yeah, because our project is built on their system, right? On the network, underground, right? We have to build on that. We have to find a way to divert, to relocate all these networks, to like insert the project in the city. Right. Yeah. But I believe they'll be solved really, really quick. Yeah. With all the corporate collaborations.
Another question,
Oh.
Eduardo Gonzalez. I would like to know the experience of this company building metros. Thanks.
Yes. So we have when we win the project, right? So we have to pass the qualification, checking by the Metro Bogotá. Yes, of course. Metro Line 1 is the local registered company. So we are the joint venture from like China Harbor and the Xi'an Metro. Okay. So Xi'an Metro is, from the name, you will know Xi'an Metro, they operate the whole metro lines in Xi'an. It's a big city in China. And also China Harbor, we have done many metro projects in different countries, right? In Malaysia, and now we're having the one in Mexico and in Philippines, okay? So, and also some project in China. You know, China, we have many high-speed train, express trains, so networks. So it's a big market. Yeah, we have a lot of experiences. Yeah.
Ok. ¿Alguna otra pregunta del el gran Beltrán pregunta, are there any images of the third rail?
Well, you can draw them. The third rail. I think I can share that through maybe after the presentation and share some sketches. Yes. This kind of just the rail beside the two rails, the running rails, right? Yeah.
Okay.
Yeah. Maybe next time.
Here.
Okay, so you said that the metro, the first line, it's very important because the standards used on this first line will rule the next lines or the next railways. Which standards have you used in the design, in the conception of this railway? I mean, there are no Colombian standards for railway, so which standards have you used? Chinese, European?
Okay, so good point. So that's also one of our questions, okay? Because there's no such specific standard in Colombia for the railway system. However, we have those international system in Europe, right? We have a standard in the British and the UK and EN Europe, and some standard from French, and I don't know where is it. Italian? Do you have a standard? Okay, so those standards are listed in one technical requirement document. So they have 1,000 of a standard listed there. So we'll have to pick for different system designs. But however, we also apply the Columbia standard for the civil work. Yeah, the CCP. Okay, so we as long as we have reference to local standard, we're going to use that. Yeah, thank you.
Hello.
Hi.
You talk about the information system in the metro, that it will let the people know where is the metro, how long it will go to the next station. And I want to know if it will be intranet network, or in internet, or in a we will be able to check this information in real time, or how we can see that.
Okay, so you talk about like some apps on your phone, then showing the latest information about the metros, right?
Right.
Well, I think that's not because we have the S.A.S. system, right? The supervision system. That's controlled by, that's put in place in the operation control center, right? For public use, I think it's quite a little bit. At the moment, we're not open to public. I think. Right?
Okay.
Yeah.
Thank you. Thank you.
Or Jackie, you have something to supplement? Or?
I don't know. One thing I would like to share is, in fact, as David just mentioned, in the station, for example, when you are in the platform waiting for the train, there will be a system telling you when the train will come, in how many minutes, and then and also there will be an indication of to ensure you are on the correct platform, and board the train to the correct direction, and to make sure you will get to your destination on time and safe.
Okay. Yeah. Just some basic information, right? Not the quite detailed, the train locations, whatever. Okay.
Next question. Pedro Botero, as far as I understand, the minimum return time at terminal stations is 110 seconds. Lower times are only possible between intermediate stations. It is correct?
Lower times are only possible between the return time at the terminal is 110 seconds. I think it's 90, right? It's 90 seconds. Yeah. It's not 110. It's 90 seconds. Like at the last station at the 72nd Street. So this is the last metro station, but we have an extension to the 76th Street. So this extension giving the return, right? I think. Stop in the middle?
Stop at the terminal. So when the train will start running again to the opposite direction, is it what they trying to ask?
I don't quite sure about the lower time are only possible.
Yeah, because normally when the train stop at the intermediate stations.
You open your mic?
Hello. I think normally when the train stop at the intermediate stations, the train will stop for around 20 seconds or 30 seconds to allow
that's
people,
for the passengers.
To allow the passenger get on board or alight of the train. But when the train is arrived at the terminal, it will allow more time not only to allow the passenger get in or out of the train, but also the operation people may do some kind of checking of the train, ensure there are no passenger on board, and also there may be sometimes they will do some kind of cleaning of the train to make sure the hygiene of the train before the next service.
Yeah, maybe that 110 seconds come from the 20 seconds for passenger and another 90 seconds for return, the turnaround. Okay. Yes. Thank you.
Another question de Vicente Benavides. According to what you have seen during this time, is it a good idea to build metro lines totally underground in Bogotá, or part underground, part elevated? No problem. Do you know answer this question?
Well, okay, so that's a very hot argument, right? But at the moment, we built the metro above the ground. That's rated, okay, according to the concession. We think the feasibility study was very comprehensive, and it's useful for the design and the build and operation. For the option of underground, at the moment I don't have a few words to say to do any like assessment to that. However, any project has to get a good feasibility studies, okay, before it's becoming a real project, okay. So it could be an option. Pros and cons has to be evaluated. Okay, thank you.
¿Alguna otra pregunta? Bueno, pues muchas gracias. Thank you very much.
Okay. So no worries. Thank you so much. Okay. Thank you for your time. Okay.
Muchas gracias a ustedes. Queremos invitarlos a este ciclo de conferencias con la empresa Primera Línea del Metro S.A.S. Dentro de 8 días estará el presidente de la Primera Línea, el señor Buyu, dando la conferencia Atrévete a pensar como un presidente de empresa. Invitados cordialmente, va a estar muy interesante. Muchas gracias de nuevo. Muchas gracias a ustedes por su presentación.
Gracias a todos.
Buenas noches.
Oh, this is next.
Universidad Nacional de Colombia, proyecto cultural, científico y colectivo de nación.